Hi everyone, my name is Marian Novotny, and in this Arsenal demo, I would like to present Siembol, an open source real-time security information and event management systems based on open source technologies. Let me introduce myself. Currently, I'm working as a software engineer at G Research, where I'm developing applications for security monitoring and intrusion detection. In past, I worked as a specialized software engineer at ESET, where I was responsible for designing and implementing network intrusion detection systems that were integrated into various ESET products. I did some research in security at university in past, where I focused on analyzing and designing security protocols. When I joined G Research, the team used Splunk for security monitoring, and that worked fine. But because of the expensive license, the team decided to build a custom security data platform based on open source technologies. And they chose Apache Metron as a core component of the platform. We started implementing missing features and plugins in Metron projects. And early we recognized the limits and issues of Apache Metron, mainly in configuration management. And we decided to start implementing a custom data processing framework in order to replace Metron internally. The transition of replacement was not straightforward, and we used to live a long time together with Metron, and we were replacing component by component. Metron was moved to Apache Attic at the same time when we decommissioned Metron internally. In my opinion, this brings the opportunity for Siembol to become an open source alternative for SIEM tools. After writing documentation and maturing code base, we decided to open source the project and contribute back to the community. We followed data pipelines from Apache Metron project, but we added components for alerting and incident response, which were missing in former Apache Metron architecture. The log after ingestion is normalized by a parsing application. It's normalized to flat JSON with common fields such as timestamp, host, or IP address. The event can be enriched by an enrichment component from tables based on configurations. For example, we can enrich an IP address by its DNS name or an asset by its classification. The events are evaluated by alerting component, and these alerts can be correlated with other alerts in a correlation alerting component. The escalated alerts are handled by a response component, which integrates Siembol with tools used for handling a response to the incident. I consider Siembol UI as the biggest improvement over Apache Metron. If you would like to scale to thousands of configurations, we need to have configuration management interface with the clean separation of duties and auditability. It should support validation and testing configurations before they are deployed into production. This is a screenshot of the Siembol UI landing page, and the list of services on the left panel is based on user authorization and permissions. Multiple service instances of the same type can be used by different teams and users in a single Siembol UI deployment. We distinguish between store and deployment of configurations. In the store, the user can edit and save configuration without deploying it into production. A Git repository is used for storing all configurations, and all changes are committed by UI under user as a committer. This way, we have a clean, auditable history of changes of configurations. At some point, user can promote the change and deploy the configuration that creates a pull request in the GitHub repository. After reviewing and merging, the configurations are released to Siembol components. The configurations are stored in a JSON form and are edited by web forms. This allows us to edit the complex configuration and provide validation in order to avoid error and mistakes. Moreover, Siembol UI supports testing configurations and creating persistent test cases that are stored in the Git repository along with configurations. Test case includes input for testing the configuration along with assertions that should pass during its evaluation. This can help to mitigate errors in the configuration that can be changed in the future by someone else than the former author of the configuration. Siembol UI is using Git for storing configurations, and all configurations are edited by web forms and stored as JSON files. Siembol UI supports OAuth2, OpenID Connect, Authentication and Authorization protocol. Authorization for service is based on the user group membership. Siembol UI supports high integrity use cases. It creates a pull request during deploying configuration. The pull request can be reviewed before merging and releasing into production. When we implemented parser in Apache Metron, it was required to write the custom Java code, compile, test, and release it in production. This process takes time and can be error-prone. We decided to build a custom parsing framework in order to speed up onboarding a new data source. A parser is created and edited in Siembol UI, similar to other configurations. First, a log is parsed by a basic parser, such as syslogs. We are supporting syslog, NetFlow version 9, and generic basic parser. Then a chain of extractors is executed in order to extract important fields from the message. We are supporting CSV extractor, JSON extractor pattern, and key value extractor. Finally, the fields are cleaned by transformations, where we can normalize values or fields. We can rename fields or filter fields of the whole message if it's not needed in further processing. This is an example of a simple parser for parsing AWS CloudTrail messages. As you can see, a JSON extractor is applied on original string, and timestamp is formatted from timestamped field event time. After extracting, the log is transformed by deleting fields which started by requested parameters resource. A parser can be integrated in a single application with a single parser, or can be combined with other parsers in a router parsing application in order to speed up onboarding a new data source. A parser is selected in a router parsing application based on a routing field. This approach allows us to maintain big parsing applications that collects logs from multiple data sources. Apache Metron used HBase for storing enrichment tables. We had issues with stability and performance of HBase tables implementation in Apache Metron, and we decided to use only in-memory tables that are sufficient for our use cases. The tables can be stored in HDFS, but we are moving to HTTP store in Kubernetes in order to simplify the deployment of tables. Enrichments are defined in rules, which are edited in Siembol UI, similar to other configurations. This is an example of enriching an IP address by a domain name, and the rule is applied after matching the field IP destination address, and the table with name DNS is joined with the event using the IP address as a key. If the table contains the IP address, then the event is enriched by the field DNS name. Apache Metron has no dedicated component for alert escalation. This feature was required by our SOC team, and we decided to build a custom framework for real-time stream evaluation of detection rules without the need to index logs. This approach allows us to scale to thousands of detection rules that can be problematic in a solution that index and queries the data. Siembol alerts are edited in Siembol UI, similar to other configurations. In this example of a simple rule, we are matching field event name with console login string and field error message with failed authentication string. We would like to add tag correlation key with value that is stored in user identity principal ID field. A simple alert can be escalated directly to a Siembol response component, or it can be used for correlation with other alerts in the correlation alerting engine. This engine allows us to describe complex threats and attack scenarios and combine alerts from various data sources. This is an example of AWS brute force login rule, and this rule we are correlating alert AWS failed authentication in 1 minute time window, and the threshold for triggering rule is set to 10. Siembol UI supports importing a Sigma rule into Siembol alerting engine. Supporting open standard formats for SIEM detection rules such as Sigma is more efficient in our opinion. And the rules created by the community can be imported easily by Siembol UI importer. And this is a screenshot of a Sigma importer. And as you can see on left side, you can define field mapping for mapping fields from Sigma rule into Siembol rule. And also you can define the mappings from rule metadata fields such as title and tags. And here you can copy and paste Sigma rule. As you can see, Sigma rule is in YAML form, and Siembol rule is in JSON, which is edited in web forms. And we are considering editing a rule using web forms with validation and testing as less error prone than the edit YAML file. And after clicking import, the rule, Sigma rule, is translated and imported into Siembol. And you can edit the rule if needed, similar to other Siembol rules. You can add a test case in order to improve the quality of the rule. Siembol response is a component for handling a response to an alert that is escalated by Siembol alerting components. In a rule defined in the Siembol UI, similar to other configurations, SOC team can automate their response to the incident by enriching alerts by doing additional ELK, LDAP, or virus total searches. Siembol response allows filtering default alerts in this stage based on rules in order to false positives and save times for SOC team. Escalated incidents can be created within internal systems such as the Hive or Jira. And let me know that Siembol response has a plugin architecture that allows the implementation of custom integrations with custom internal systems if necessary. And this integration is also integrated with Siembol UI. So you can edit a rule, you can edit Siembol rule with custom evaluators from plugin, similar to other configurations. Siembol architecture was designed with aim to scale with number of events and configurations and quickly adapt to changes in technologies. This is a full picture of Siembol components, and we try to decouple components if possible. Siembol UI adopts microservice architecture, where single-page application is developed in Angular and REST API in Java Spring Boot. Siembol UI is using identity provider for authentication and authorization using OAuth2 OpenID Connect protocol. And it's using GitHub for storing configurations and managing pull requests. Siembol REST API adapts the modular architecture in order to validate and test configurations. It includes the same modules which are used in the Siembol Storm applications. One exception is Siembol Response with microservice architecture, and Siembol REST is using HTTP calls for testing validating configurations in Siembol Response, because Siembol Response loads plugins, and we would like to avoid loading the same plugins in multiple components. Siembol adapts desired state pattern in order to release and kill storm topologies. The desired state is computed by Siembol REST from Git configurations and synchronized using Zookeeper. Storm topology manager kills and starts topologies based on the desired state. Siembol can be deployed with an external Storm cluster and orchestrated from Kubernetes using Siembol Storm Topology Manager component. This was our initial deployment. However, we prepared a Helm chart for Apache Storm, and we are moving to Storm Kubernetes deployment internally. Siembol REST sync service computes the desired state of Siembol Storm topologies from configurations stored in Git repositories. The state is published in Zookeeper and consumed by Siembol Storm Topology Manager. The manager is using API of Storm UI in order to kill Siembol topology, or it can launch Kubernetes jobs in order to start the new topology. The jobs are using Docker images with Storm CLI, Siembol jar files, and arguments for starting topology that are encoded as base 64 strings and are passed into main function during topology initializations. The topology is built pragmatically in the main function. We used open source Bitnami charts for Zookeeper deployment, and we prepared and published Helm charts for Apache Storm. The Storm state is stored in Zookeeper, except data which are used by Nimbus, such as jar files or metrics, and they are stored in persistent volume claims. This way, only Nimbus is defined as a stateful set, in contrast to Storm UI and Supervisor, which are defined as deployments. Workers are launched in Supervisor deployment, and this way we can easily scale up with number of replicas in Supervisor deployment if needed. We are using OAuth2 OpenID Connect for authentication and authorization with standard claims for email and groups. They are used in Siembol UI. Siembol UI supports OpenID Connect protocol natively, and Siembol REST is a resource server that verifies JSON web tokens issued by an identity provider, and config editor UI as a single page application is initiating a code flow with identity provider in order to obtain the token, which is used in each call to configurator REST server. On the other hand, Storm UI doesn't support OAuth2 OpenID Connect authentication, and we are using open source tool OAuth proxy with combination with Nginx OAuth2 ingress in order to secure services that are not supporting auto protocol in Siembol. Siembol CI/CD pipelines on public GitHub repository are building 7 Docker images. 3 of them are Siembol Storm applications, 3 of them are Siembol Spring Boot applications, and 1 single page applications. CI/CD pipelines is releasing Java packages to Central Maven, and we are publishing Helm charts for Siembol and Apache Storm in order to deploy Siembol on Kubernetes cluster. Siembol can be used as a SIEM tool based on open source big data technologies that can replace expensive solutions. Siembol Architectures allows processing 250,000 events per second currently at the GR, and we are onboarding 90 data sources and evaluating around 300 detection rules. The rules were released 750 times with auditable Git history of each release. This is computed in 27 Storm applications, but we believe that architecture allows us to scale up with number of events and number of configurations. Siembol can be also used as a detection tool for detecting leaks at infrastructure. Internally at GR, we are using Siembol for detecting leaks on HTML files that are moved between zones. This approach can replace expensive tools and can be used for detecting leaks on other platforms too. Moreover, in Siembol UI, we are supporting importing Sigma rules. This way, Siembol can be used for real-time evaluation of Sigma rules without need of index or store logs. Demo, we are following quick start guide from GitHub repository. We prepared scripts for installing Minikube and dependencies, such as Apache Storm, Kafka, and Zookeeper. And moreover, we prepared Git repository with simple configurations that can be used as inspiration for someone who would like to try Siembol. In this repository, we prepared a few parsers alerting an enrichment instance. So you need to fork this repository and also create personal access token that can be used by a Siembol UI to access this repository. So you need to add a repo scope into the token. And then we can go to next stage and try to run the demo install script. This script will create Zookeeper nodes and also secrets and config maps which are generated from inputs from GitHub repository, and it includes GitHub username, URL, repository name. This is name of the fork, and also personal access token that was generated for this purpose. Then if the scripts will create secrets and config maps, we can go to next stage and we can try to install Siembol. Now Zookeeper nodes are generating. So we are checking whether everything is running, so we are ready to install Siembol. And in Siembol config repository are few applications that are expecting to be released. The applications are computed by configurator REST, and Storm Topology Manager will launch jobs in order to launch these topologies. So now we are checking whether it was initialized and whether jobs are releasing. Now you can see 5 jobs are creating and running. So this means that in Storm UI, we will see soon 5 topologies. Siembol Storm topologies are orchestrated by Storm Topologies Manager from Git configurations. In this case, the configurations are in Siembol-config repository. Now we can inspect Siembol UI. As you can see on the left side, there are services from this Siembol config repository, and we can have a look on WinEvanLog's parser. This is simple syslog parsers with key value extractors. It can be edited by web forms, and we prepared 2 test cases, and 1 test case contains a log that will match Mimikatz rule. And this is example how can we modify config, how can we submit config, and how can we deploy configuration. So now we made simple change, we submit this change that increased version of configuration, and now we would like to promote this new version into deployment. By clicking deploy, Siembol UI creates a pull request in GitHub repository. And after merging this pull request, the configuration will be synchronized with the configurator REST if you have configured webhooks. This is an example of a simple enrichment rule. We are enriching host name based on tables from IP address. And as you can see in test case, contains event, but also it contains simple table mapping to test configurations. And this is a simple alerting rule for matching Mimikatz. As you can see, Siembol alerting rules can be edited in UI similar to other configurations. And also it supports test cases. Test cases contains input event and also few assertions that are evaluating during evaluating test case. Siembol UI supports importing Sigma rule, and this is example of rule copied from Sigma GitHub repository. So we just copy and paste Sigma rule, provide source type, which is required field, and after clicking import, the rule is imported into Siembol alerting. We can now modify the rule. We can add a test case in order to improve the quality of the rule. Now we will install a simple enrichment table in order to demonstrate enrichment functionality. We are uploading a table with host names and with a simple mapping of IP address 1234 to test name host. And also we are installing Kafka UI in order to demonstrate communications of Siembol components. So we are also installing the Kafka client in order to send message for parsing. We would like to send message to win.eventlogs topic, and this message contains a log that will be matched by alerting rule for Mimikatz, and also will be enriched by enriching rule for an enriching host name from IP address. So we will copy log from test case. And as you can see, this log has IP address 1234. Okay. After publishing to win.eventlogs, this topic is consumed by eventlogs parser. And first we can see communication on win.eventlogs topic. And we can see that we sent one message, that is one line of syslog message. And this message is parsed by win.eventlogs parser and published to Siembol.enrichment. And this topic, Siembol.enrichment, is consumed by enrichment. As you can see, this one line syslog message was parsed into flat level JSON, and enrichment, after enriching, publish message into Siembol.indexing. And this message was enriched by enriched hostname, test name based on a table which we uploaded in this demo. And Siembol.indexing is consumed by alerting component. And as we can see, the rule for Mimikatz, Win Mimikatz version 1 has matched. As you watched in demo, we prepared a quick start guide with simple deployment on Minikube and a Git repository with Siembol demo configurations. In this demo, Siembol has disabled authentication, but we are working on the version with enabled OAuth 2 OpenID Connect authentication using common identity providers. Later, we would like to also prepare the cloud testing deployment. If you decide to try Quick Start Guide, feel free to discuss issues, provide feedback, or ask for help using GitHub discussions. Siembol is not a one-man project, and I would like to thanks to all Siembol contributors. And if you are interested in the project, please visit our webpage, siembol.io, or have a look at the Siembol GitHub repository, gresearch/Siembol. Thanks for attending the Siembol presentation.